In this video, I will talk very briefly about second fundamental theorem of calculus. So here is what the theorem says. Suppose f is a function that is continuous on an open interval containing a. Then for every x in the interval, the derivative of this integral from a to x of f of t with respect to t is simply f of x. Let's look at a couple of examples. So it says use the second fundamental theorem of calculus to find dy by dx if y is given like this. So using the second fundamental theorem of calculus, which is this formula right here, we simply have dy by dx equals derivative of this integral 2 to x fourth root of t dt. And then, so you see the value of a in our case is 2. So in this case, a is 2, and the function f of t is fourth root of t. Then the theorem says this must come out to be f of x, which is fourth root of x. Therefore, we get the derivative of y equals derivative of y with respect to x equals fourth root of x. Quite straightforward. Let's look at the next example. So next we have y given as 2 to sine x, 4 square root of t with respect to t. So in this case, a is again 2, but our x as the upper limit of integral is replaced by sine x. So it's not quite like what we have in the formula, but we can make it look like what we have in the formula by letting u to be sine x. And then we try to write the whole integral in terms of u. Then y equals integral from 2 to u of fourth root of t dt. So now we are ready to find dy by dx. dy by dx. But if you look at this function here, the way y is expressed, it's in terms of u. So we need to apply the chain rule, which says du by dx times dy by du. So du by dx is simply the derivative of sine x, which we know is cosine x, times, and dy by du will simply be the derivative of this integral because y is this integral. So 2 to u fourth root of t dt. And now applying the second fundamental theorem of calculus, this second part comes out to be fourth root of u. And now we can finally have our answer in terms of x. Because we know what u is in terms of x. U is simply sine x. We get this. So therefore, dy by dx equals this expression.